Alright, in this lesson 4.2, we're going to start talking about matrix multiplication. Now, many times when we start a lesson, we learn the technique or we learn the process, and then we work our way into word problems. We're going to do that a little backwards with this lesson. We're going to try to look at a word problem to hopefully help you understand why we multiply matrices in the way we do. This particular word problem talks about the Cuddly Toy Company, and they make 3 types of stuffed animals: pandas, kangaroos, and rabbits. The production of each toy requires to cut some material, sew it, and finish it. And they have orders for October and November. And so we have 2 matrices listed here. And they are this first one right here, and that talks about the number of hours of each type of labor required for each type of toy. And the second matrix, which is here, talks about the number of each type of toy every month. What's important to notice here is that, well, that's interesting. The whole slide just left. Let me get that back. The important thing to notice here is that the labels across this first matrix's top, which are the columns of that matrix, match the labels along the row of the second matrix. And so if you think in terms of dimensions, that means that the second dimension of the first matrix is the same as the first dimension of the second matrix. And so let's just write our dimensions. On this matrix 1 here, our dimensions are 3 by 3. That's a 3 by 3 matrix. And on this second matrix, there are 3 rows, but there are only 2 columns. It's a 3 by 2 matrix. And so, but you do have to notice that this matrix, this dimension and that dimension represent the same labels. We kind of call those the inner, I call those the inner dimensions when you look at the 2 matrices. And they match because the labels are the same. So let's go on and just think about this in terms of how we would solve a problem, not knowing anything about matrices, but just using this as a way to have information given to us. The company wants to know how many hours of cutting labor are going to be needed in October. Well, they're going to cut 3 different kinds of toys, and those are different. So what they're going to do is they're going to first figure out how much it's going to cost them to cut. Let me see if I can get a different color on the highlighter. To cut pandas. So they're going to multiply the time needed, the hours to cut 1 panda times the number of pandas they have ordered in October, which is 0.5 times 1,000, and that's going to be 500. So they're going to take 500 hours to cut pandas. Notice I multiplied this blue in the first matrix times the light blue in the second matrix. Now we want to know how many hours it's going to take to cut kangaroos. Well, they're different. There's 0.8 hours for every kangaroo, and there were only 600 kangaroos ordered. So we're going to multiply 0.8 times 600, and that's going to give us 480. So there were 480 cutting hours associated for the kangaroos in October. And next we need to know how many hours it's going to take us to cut out the rabbits in October. So let's figure that out. And so there's 0.4 hours for every rabbit, and there were 800 rabbits ordered. So we multiply those kind of orangey that I've highlighted in orange together, and you will get that the hours required to cut rabbits in October were 320. So you write that down. Now I've got those by multiplying those two figures together, one from each matrix. The total numbers of hours, then I would take and I would add all of these together. Okay, and the total numbers of hours required in October then are 1,300. So it would require 1,300 hours in October just to figure out the cutting hours in October. Now let's do sewing hours. So sewing hours, we have to go back to our matrix, but sewing is now in our second row. So we're going to take out this first row information, and we're going to look here at our second row, the sewing row. Okay? We still need pandas, kangaroos, and rabbits. So first thing we're going to do is multiply the panda hours, the 0.8 times 1,000. That's the hours it would take to sew pandas in October, because there were 0.8 hours for every one panda. There were 1,000 pandas ordered. So the sewing hours needed, well, I keep marking on it. The sewing hours needed for pandas then are 800. 0.8 times 1,000. Now we have to go back and we need to figure out for kangaroos. Well, for every kangaroo we need 1 hour of sewing. There were 600 of them ordered. Well, 1 times 600 then, it's going to require 600 hours of sewing in October. And for the rabbits, okay, so for the rabbits it's going to require a half hour for the 800 rabbits that were ordered. Multiply those two numbers together, and for rabbits in October it would take 400 hours of sewing. Now to figure out the total amount of sewing for all three animals together in October, we would add up those three sets of numbers that we got, and it would take 1,800 hours in October okay, to get the sewing hours. So let's go back and look at the process that we've used. Hopefully you can recall and think about it. The process that we've used is we've multiplied each number in this first row times each element in this first column and gotten a number right here. Okay? Then we added them all together, and that's the answer that will be in our final answer matrix. And we will put that in the matrix on the next page, that 1,300. So let's just go over to the next page right now, and we'll put it in there. That 1,300 would go right here for the total cutting hours needed in October. Okay? Now we're going to go back and look at how did we get the sewing hours. Well, instead of the first row, we multiplied, and let me just use a different color. Let's go back and pick up a different color. We used the second row, but we still used the first column because we're still in October. We multiplied the first element by the first element, the second element by the second, the third by the third, and then we added them all together here, and we got 1,800 as our total amount of sewing hours for October. So we're going to go over to the next page, and for sewing hours in October, that would be 1,800. Now we do that same process for finishing in October. We would multiply this, this row by this column, 0.6 times 1,000 plus 0.4, so let's write out what we're actually going to put. we'd have 0.6 times 1,000 plus 0.4 times 600 plus 0.5 times 800, and that would give us the finishing hours in October. And so then we go over here and we put it where we have finishing for October, and that adds up to be 800. Okay. Now to finish our answer matrix, we've got to go to November. So we have a different column this time. We're going to use the same rows, okay, that we did before. But now we've got to start back over for cutting, but we want November this time instead of October. So for this particular set of numbers, you would do 0.5 times 1100 plus 0.8 times 850, first times first plus second times second plus third times third, which is 0.4 times 725. And then that's going to give us, when we add those all together, that's going to give us 1520. And I had a mistake there. But this is going to give us 1520 for November. And this number, I don't know where I came up with 800. This number here should be 1240. So I have to apologize for that. Now let's go and do the sewing in November. So let's erase. Okay. We want the sewing now in November. So now we're going to do the middle row times the last column. And that's 0.8 times 1100 plus 1 times 850 plus 0.5 times 725. Add those all together, and you can do these in your calculator, but that should be 2092.5. I'm kind of getting outside my matrix is marked, but I can't write that small. And lastly then, to finish filling out this problem, okay, we're going to have to do the last row by this second column for November to get the finishing hours in November, and that would be 0.6 times 1100 plus 0.4 times 850 plus 0.5 times 725. And when we multiply those individual parts, and make sure my decimals are there, and then add them all together, you're going to come up with 1,362.5. And that gives you the finishing hours in November. Now, I want you to go back and let's think about the dimensions. We already talked about the inner dimensions being the same because the labels are the same here and here. And so let's go through and look at our dimensions. This was again a 3 by 3. We did this already on the first page. This one is a 3 by 2. Our inner dimensions match. Now, notice what the dimensions of the answer matrix are. They are 3 by 2. And those come from these outer dimensions. That will give you that will tell you how big your answer matrix should be. So, these have to match right here, these inner dimensions, because they match the labels. If those don't match, you cannot multiply the matrices, and so you just have to say it's not possible. You can't do it. Then, if they match, they can be multiplied, and the outer dimensions tell you your answer matrix. So let's look at this question number 1. Can these matrices be multiplied? This first matrix is a 2 by 1, and the second matrix is a 2 by 2. Notice those numbers are not the same, so the answer is no, those cannot be multiplied. Looking at question 2 here, okay, looking at question 2, this first matrix is a 2 by 2, and the second matrix is a 2 by 3 matrix. These numbers match, so it can be multiplied, and then you say what will be the size of the answer matrix down here, and the answer to that is it's a 2 by 3. So our new matrix, if we did the multiplication, would be a 2 by 3 matrix. So let's go ahead now and multiply those two matrices. That's down here for problem 3. And get some practice. Now this time we're doing it without labels, and so that's why sometimes it doesn't make as much sense. But let's look at it, and I'm going to try to show all the work, and that gets a little bit tedious, but let's go ahead and show all the work for the first time around. So remember, the first thing we do is multiply the first row times the first column. So you have 4 times negative 1 plus 2 times negative 2. And so in our answer matrix here, that's going to be negative 4 plus negative 4, which is negative 8. Okay. Now in the middle spot, we're going to multiply the first row now by the middle column here. Okay. So that's what we're looking at now. And so we have 4 times 3 plus 2 times 0, which is 12 plus 0, because anything times 0 is 0. So that answer in that spot is going to be 12. And now the last multiplication we're going to do is the first row times the last column, and it goes in the first row in the third spot in our answer matrix, and that's going to be 4 times 5 plus 2 times negative 6. Okay, which is 20 plus negative 12, which turns out to be 8. Okay, very good. We've done that multiplication from the first row in the first matrix across all the columns in the second matrix. Now let's go down to our second row, and we'll start by multiplying it by the first column. And so we're going to have negative 1 times 1, negative 1, excuse me, plus 3 times negative 2, which is positive 1 plus negative 6, which will be negative 5 when I add it together. Okay. Now we'll go and multiply that row by this middle column for our middle spot on the bottom, which is negative 1 times 3 plus 3 times 0, which is negative 3 plus 0, or negative 3. And for our last spot then, we're going to multiply that row, that second row, by the third column. And so what we'll end up is negative 1 times 5 plus 3 times negative 6, okay, which is negative 5 plus negative 18, which ends up being negative 23. And then that's our answer matrix. And it is, again, it should have been 2 by 3 dimensions, and we notice that it is, in fact, 2 by 3. So that's the process without labels, row by column. Multiply each part of each row by each that corresponding part of each column, and then add them together for that spot in the answer matrix. Now let's look at number 4. This matrix is a 2 by 3, and this matrix is a 2 by 2. So we're going to notice, first thing you have to check is you have to check your dimensions first. These don't match, so this one is not possible. Alright, let's do a couple more examples. Number 6, first thing we're going to do is check dimensions. We have a 3 by 3 multiplied by a 3 by 3. So, as expected then, our answer will be 3 by 3. That tells us we can multiply it, and these tell us the dimensions of our answer matrix. So, let's go through. Now, first of all, we're going to multiply 7 times 1 and get 7. Then negative 3, again row by column, times 0 and get 0. And then 2 times negative 7, which is negative 14. Okay? And so that will give us a negative 7. Okay? Now let's look at the middle thing. What should be in the middle here? Okay. We're going to have, let me go ahead and erase some of these. We're going to go first row times middle column. 7 times 0 is 0. Plus negative 3 times 8. We've done this one. Negative 3 times 8 is negative 24. Plus 2 times 9 is 18. Negative 24 plus 18 is negative 6. So that's what's going to go in the middle right there. Now, first row times last column will put us in our first row, last column spot in our answer matrix. We have 7 times negative 5, which is negative 35, plus negative 3 times 7 is negative 21, plus 2 times 6 is 12. And we add all those together and get negative 44, which goes right there. Now we're ready to move down to the second row, first column. 0 times 1 is 0, plus 8 times 0 is 0, plus 1 times negative 7 is negative 7. So that's going to put negative 7 in that spot in our answer matrix. So we're going to, okay, middle row, middle column will put us in middle row, middle column in our answer matrix. 0 times 0 is 0. Plus 8 times 8 is 64. Plus 1 times 9 is 9. So 64 plus 9 is 73. That's going to go right there. Now let's do our middle row times our last column. 0 times negative 5 is 0. 8 times 7 is 56. And 1 times 6 is 6. So 56 plus 6 is 62. Now we're ready for the last row. And this is a lot of practice. It's the same thing over and over. But hopefully by seeing it enough times, you'll get the hang of multiplication. Remember, part of your test is without a calculator, so you have to know how to do these. So, Last row, first column. 8 times 1 is 8, plus 6 times 0 is 0, plus negative 6 times negative 7 is positive 42, which is going to end up being 42 plus 8, or 50. Now we're going to, if I can get the eraser to come on, come on, here we go, maybe that got it. Alright, now we're going to do first row, middle column. 8 times 0 is 0, excuse me. Plus 6 times 8 is 48. Plus negative 6 times 9 is negative 54. So 48 plus negative 54 is negative 6. And the last thing to do, which we're ready to be the last thing to do, is this last row times the last column, and that goes in the third row, third column spot in the answer matrix. So we have 8 times negative 5 is negative 40, plus 6 times 7 is 42, and plus negative 6 times 6 is negative 36. So negative 40 plus 42 minus 36 is negative 34. And that then is our answer to this matrix multiplication problem. Okay, let's look at number 6. Just make sure we can do that one. This is a 3 by 2 matrix multiplied by a 2 by 3 matrix. And our answer, these match, our answer will be 3 by 3. So our answer is going to be the same dimensions as when I multiplied the number 5. So let's put the big spot here to write answers. Again, we're going to do first row times first column. 1 times 4 is 4, plus 0 times 2 is 0. Right? Then we have the first row times the middle column. 1 times 3 is 3, plus 0 times negative 1 is 0. Then we have the first row times the last column. 1 times negative 2 is negative 2, plus 0 times 5 is 0. Okay? Start over with the middle row, first column. 0 times 4 is 0, plus negative 1 times 2 is negative 2. Middle row, middle column. 0 times 3 is 0. Negative 1 times negative 1 is positive 1. And then middle row, last column. 0 times negative 2 is 0. Negative 1 times 5 is negative 5. And last row, 2 times 4 is 8, plus 3 times 2 is 6. Two times 3 is 6, plus 3 times negative 1 is negative 3. And in our last spot on our answer matrix, 2 times negative 2 is negative 4, plus 3 times 5 is 15. And so when we add those together for our final answer matrix, you have 4, 3, negative 2, negative 2, 1, negative 5, and 14, 3, and 11. And that's your final answer for number 6. Okay. Number 7, we have a 2 by 3 matrix multiplied by a 3 by 1 matrix. These match. So our answer matrix is going to be a 2 by 1 matrix. So it's going to get smaller. Sometimes they can get bigger than any of the initial ones. Sometimes they can get smaller. You just have to kind of look at what you're given. So again, the process is the same. Let's go through and do our multiplication. We have 4 times 2 is 8, plus 3 times 4 is 12, plus negative 2 times negative 1 is 2. That's our first row times our only column. Now we have to do the second row times that column. So you're going to have 2 times 2 is 4, plus negative 1 times 4 is negative 4, plus 5 times negative 1 is negative 5. Okay, and then our answer matrix, our 2 by 1 answer matrix, 8 plus 12 plus 2 is 22, and 4 minus 4 minus 5 is negative 5. And so that's our 2 by 1 answer matrix for number 7. Now let's look at number 8. We have a 2 by 2 matrix here and a 1 by 2 matrix here. Our numbers do not match, as the inner numbers don't match. So we're looking at an answer of not possible. It's not possible to multiply those two matrices.